Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Today, we are going to discuss ideal gas equation, which is also known as combined gas law. This ideal gas is combining Boyle's law, Charles' law, and one more, which is Avogadro's law, gave the ideal gas equation. So according to Avogadro's law, it states that volume proportional to mole. According to Boyle's law, pressure is proportional to 1 over V. And according to Charles' law, volume is proportional to temperature. And in all the three laws, volume is the common things in between them. So therefore, if you want to combine the three laws, volume is proportional to mole, proportional to T, and inversely proportional to P. So if we multiply P up here, then we're going to get a constant. And the constant right now is known as the molar gas constant. Therefore, PV will be equals to nRT. In order to calculate any one of this, we will have standard unit for each of them. The pressure of the gas must be Pascal, or it could be Newton per meter square. The volume must be in meter cube. The temperature must be in Kelvin. Therefore, we call this temperature as absolute temperature. R is a gas constant, and it is always constant at 8.31 joule per mole per Kelvin. And this unit can be obtained from the data booklet. Alright, so right now we are going to look at this. Sometimes in the past year questions, the given unit is not the standard unit. So therefore, we must be able to change the unit to the standard unit. For example, 1 ATM, it will be equals to 1.01 times 10 to the power of 5 Pascal. We know that 1 Pascal is equals to 1 Newton per meter square. So therefore, this 1 ATM is also equals to 1.01 times 10 to the power of 5 Newton per meter square. Now let's look at the second one. 1 cm cube. It will be equals to how many meter cube? So now let's think back. 1 cm is equals to 1 times 10 to the power of -2 meter. If we want to cube it, this will be cubed and this will be cubed. So therefore, 1 cm cube is equals to 1 times 10 to the power of -6 meter cube. Whereas 1 dm is equals to 1 times 10 to the power of -1 meter cube. Therefore, if we want to cube this, this will have to cube as well. Alright, so it will be equals to 1 times 10 to the power of -3 meter. So the next thing is to determine the molecular masses. For n mole of gas, we know that PV equals to nRT. Knowing that n is the number of mole and the mole calculation is mass of the gas in gram over the mR of gas in gram. So therefore, PV equals to nRT, and when we want to substitute the mole by using mass over mR, this is what we get. And when we rearrange these equations, then we'll calculate the mR in terms of nRT over Vp. Alright, and knowing that mass over volume is also density, so therefore another equations arrive equals to mr equals to mRT over Vp. The m over v can be changed to density RT over P. This is May June 04. Use of the data booklet is relevant in questions B and C. Questions B. The ideal gas is PV equals to nRT. Explain as fully as you can the meaning of the following terms and give the units for each of the correspond with the value of R given in the data booklet. Now let's look at number 1, P. So P means the pressure of gas. And the units can be either Pascal or Newton per meter square. Whereas number 2, V means the volume of the containing vessel. And the unit could be either meter cube, dm cube, or cm cube. Whereas number 3, T means the absolute temperature. Where the unit can be either K or it could be degree C, but we need to plus 273 degree. Okay, each of this is 1 mark, so therefore you will get 6 marks altogether. Question C1. When an evacuated gas bulk of volume 63.8 cm3 is filled with the gas at 24 degrees C and 99.5 kilopascal, the mass increases by 0.103 grams. Deduce whether the gas is ammonia, nitrogen, or argon. In order to do so, we will need to look for the MR. So we can start from expanding PV equals to nRT. Knowing that mole is mass over MR RT. So if we rearrange the equations, MR will be equals to mRT over Vp. Well, now the mass is 0.103. The R is a gas constant at 8.31. The temperature used is 24 plus 273 over the volume of gas is 63.8, and since it is in cm cube, we will have to change the unit to meter cube by multiplying with 10 to the power of -6. Multiply with the pressure is in the unit of kilopascal, so we need to change it to pascal. Therefore 99.5 multiplied with 10 to the power of 3. So you will get 40. If you check from the data booklet, the gas is argon, since argon has the MR of 40. Now let's look at these questions. A gas has a density of 1.7 gram per dm cubed at 1273 degrees C and at a pressure of 200 kilopascal. Calculate the relative molecular mass of the gas. We will need to change all the non-standard unit to the standard unit. Alright, now since PV equals to nRT, mole equals to mass over MR RT, And if you want to look for a density, MR equals to MRT over VP. So M over V will be equals to density. MR equals to density RT over P. Alright, so now we're going to substitute all the relevant value into this equation. In order to find MR, the density is 1.7 gram per dm cubed. However, the dm cubed is not in a standard unit, so we have to change it. 1.7 gram over 1 dm cubed. From my previous class, I've told you that 1 dm cubed have to change it to meter cube by multiplying 10 to the power of -3 to meter cube. So this is how we change the unit for density. R is 8.31. T is 127 plus 273. Over pressure is 200 times 10 to the power of -3. So if you solve this equation, then you'll be able to get the answer without any unit. Next, we're going to look at October-November 04, questions 8. Use of the data booklet is relevant to these questions. Which expressions gives the pressure exerted by 1.6 times 10 to the power of -3 moles of N2 in a container of volume 3 dm cubed at 273 degrees C? So knowing that PV is equals to nRT, in order to obtain pressure, it will be equals to nRT over V. So the number of mole is given, which is this. R is a constant and the temperature is in a non-standard expression. So the standard expression should be in Kelvin. So in order to change the temperature to this absolute temperature, 273 must add 273 in order to change it to Kelvin. Whereas the volume, which is in 3 dm cubed, has to change it to meter cube by multiplying 10 to the power of -3. So number of mole is this. This is 8.31. So this is the temperature and this is the volume. The answer is D.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.